So I'll give another few seconds for them to show up. All right, while we wait for them, the first few minutes, if anyone had any questions about last week's things, remember last week we talked about variables, configurations. So if you had any trouble with that, ask any questions. All right. So we don't quite have everyone, but I think we can get started. As usual, I'll be doing a little overview. I know not all of you were in the previous CAD classes. So for the benefit of those of you who have not seen some of these things before, especially drawings, which will be an important part of what we do today, I'll have a quick review at the beginning. So when we talked about a drawing, as some of you heard before, specifically an engineering drawing, it's something like this, where you have a representation of a part, you show it from multiple different views, and there's enough information on this drawing and no more. It's just the minimum amount of information that you need for someone to be able to recreate this, whether that's on a machine and creating the object on real life, or perhaps creating a model. So as we talked about in previous classes, what you'll commonly see in these types of drawings are various types of lines. So we have our solid lines that denote the edges of a part. We have hidden lines. In this bottom left view here, you can see some dashed lines that represent parts of the geometry that are there but are covered up by something that's in front of it. We have center lines, which are just a tool that's used to tell you that something is symmetric. So here we have a center line going here that indicates symmetry. And you might see some other things. They aren't in this drawing, but you might see various views that let you see different angles, or in the inside of a part, or a close-up view of a part where there's a lot of details going on. So what we're going to be doing today is working basically from drawings. They won't quite look like this one, but you'll need to be able to read dimensions, figure out how long something is supposed to be, what angle things are supposed to be at, what radius various fillets are supposed to be at. And you might have to do a little bit of math with these drawings just to figure out everything, but I have used these drawings that you're going to use to make the parts as I usually do. So I can confirm that the drawings do have enough information for you to fully define everything. So if you do have a question, you can ask as usual. I think we have a few more people, so I'll introduce this week's challenge. I'm sure some of you have heard of SolidWorks before. It's a very popular CAD program. I personally use it a lot. But the relevant point is that the company that makes SolidWorks, they're called Dassault Systems. They host an event every year, kind of a convention. And at that event, they have a bit of a contest called the SolidWorks Model Mania. So you can look it up yourself, go to this blog page. And I do want you to go to this page where you can find every model mania model from the past 20 years or so. And what you'll find is for each of these, they do have a drawing. In the actual competition, they have 2 phases, but we're mostly just going to worry about phase 1. So if you click any of these links, it'll take you to one of the drawings. And I picked out 3 options that are perhaps the easier ones to do. They're more straightforward. They don't have quite as much tricky things that you have to do to create them. So these are 2014, the 2017, and the 2020. And so the idea for the class is you'll pick one of these. I'd recommend that you pick one of these 3 just because I've confirmed that you can do them. And you can find the drawings on that website. Hopefully, if you can finish one in class, that's great. But don't worry if this takes you most of the class or longer than the class. I did write in the homework submission for this week, if you didn't finish the one in the class, just submit what you had at that point, like maybe take a screenshot or something, submit that at the end of class. But then by next week, you can continue working on it, just finish that one, and you can submit that one as the homework. So that's if it does take you too long. So take a good look. If you can't get to this and you can't access the drawings for some reason, send me a message or say something. But that's what you'll be doing. In terms of other things, I will show you a few things that will be useful. Some of them you've seen before, some of them might be new concepts. So if there are any immediate questions about what I just said, please ask. But if not, I'll go into a quick demonstration. All right. So the first thing I want to talk about is not so much of like a new feature in particular, but more of a concept. So let's say that I'm making a plate that has to be mounted to another part, right? And so if that part has bolts on it, like we saw in CAD 3, you might be interfacing the base of a robot arm to a frame, and you already have a pattern of bolts. So on the part that's interfacing with that, you need to have a hole pattern that matches up with the bolt pattern so that the two will fit together. And in a lot of cases, it'll turn out that the pattern in which you have your bolts is a circle. So in that case, what you can do is make use of your construction geometry, where you create a construction circle. And maybe I want a bolt circle like this. What I can do is kind of create this construction geometry. which allows me to place multiple circles perhaps, or I could use a sketch pattern. And so the main idea here is that when you define your bolt circles this way, instead of just doing the alternative, which is specifying the XY coordinate of every single hole. First of all, this is less math because sometimes the position of a bolt hole might be an irrational number. For instance, if I had, say, a pattern of 3 here, if I had something like this, then the X position of this hole would be an irrational number. Which you can see, it's not something neat. So it's better for me to specify a bolt pattern that's a circle in this way, just because it's more robust. I can change it more easily. It's more in line with the design intent, where the way I think about it in the design phase is not so much the XY position of every hole, but how these holes are related to another point. So that's something that might be useful to you as you look at some of these parts. Another thing is, this is something that you've seen before, but perhaps you may not think about it. And that is the sketch offset. So this one will really save you a lot of time if you pick one of the, if you pick a specific one, this will save you a fair amount of time. If you have a sort of strange continuous line that closes off a region, something that you can do is use your offset tool. So in your sketch, it's looks like this. And what it allows you to do is to select certain parts of the geometry and specify a distance. And what it'll do is it'll create basically a version of that that is uniformly a certain distance away from your original profile. So you can imagine if I wanted to create this interior boundary, this boundary, by hand without this tool, I would have had to draw all of these lines. I would have had to dimension each and every one of them specifically relative to these other lines. And I would have had to recreate a lot of the constraints. And so a lot of the effort there is saved just by having this offset relationship. So if you've seen that before, it's great. Just keep it in mind. It might help you for one of these. And the last thing is the shell tool. I know we talked about this in the past as well, but let's say that we want to do a revolve to create some kind of shape. So really quickly, something like that. Make it a shape like this. And let's say my intent is for this to be hollowed out. So I want it to be a thin walled structure instead of a solid object like it is right now. That's where I can use the shell feature. And what the shell feature takes in is a face. It doesn't have to be like a flat face, but it can be. And what it'll do is it'll kind of follow along the entire extent of the solid object, and it kind of opens up that face and makes the rest of it hollow. So kind of showing you what that means. I selected the flat face there, and what it did was it preserved all the other faces that existed, but then it hollowed out everything else in the solid body, starting at that face that I selected. So I could have chosen a different face and something different would have happened. If I choose this interior cylindrical face, you can see the interior is now hollowed out. And if I'd instead chosen perhaps this face, then it gets hollowed out as such. So this one will also prove useful for one of the drawings. In terms of CAD tools, I did try each of these, so I didn't have to use any tools that we didn't talk about during this class, but in case I overlooked something, maybe if you have any questions, feel free to ask as you go through them. Just to go through the drawings together, these are the three that I selected. I will point out a few things. This is an example of a section view. So here it's labeled section A-A, and what that means is that it's showing you the cross-sectional view of if you were looking into the slice here. So here you can see there's a line with arrows on it that's marked A and A. So if you cut that piece along that line, and then you took it, you held it up, and you looked into where you just cut, this is kind of what it would look like. Here, I know all three of these drawings say that that all dimensions are in millimeters, but that's not too important. Just use the same dimension for everything. I just made everything in inches, and they were really big, but that's all fine. As you look at these, if there is some like wording that you don't understand, feel free to ask about that. I'll point out some things like, you'll see this, it says R3 typical all green fillets. That just means every single fillet that you see here has a radius of 3. If you see like the word 3 tip here, that just means every thin-walled part of this structure has a dimension of 3. So with that knowledge, everything here is like fully dimensioned. Here, again, we see R2. So every fillet has a radius of 2. And if you choose this one, I do want to kind of tell you in advance, it might be easier to just extrude these cuts instead of using the hole feature. I know we've talked about how it's usually better to use the hole feature just because it has a lot more options and selects the standard sizes for you. But in this case, it is just these numbers that fully describe the hole. So just because of the way that the counterbore is defined, it might be easier for you in Onshape just to make the extrusions. Here you can see what is meant by the bolt circle. That's the first thing I demonstrated, where you have a circle and that circle kind of constrains the position of the bolt holes. And so if you happen to want the slides, they are posted on Classroom. Hopefully you've all been able to find that blog that has the drawings. And from this point on, I'll just give you guys time to work on it. Again, I don't expect this to be easy. There are times where we have to do a bit of math. You'll have to try to think about how these dimensions relate to each other. And you'll have to be a bit clever with the features, but everything that's here is doable. And everything that's here uses only things that we've talked about. So I have full confidence that you'll be able to make good progress and just ask questions when you need to. If you want to kind of turn the object around visually, I do have the models available, which you can look at. And for today, I'll check in with you a bit earlier than usual. I might make 2 rounds this time, just because it might be a bit more involved than what we've done so far. Maybe a few more minutes, and I'll start calling on people.
Hi, Alex. You just joined the class. You probably missed the big part of the class. So, is it okay for me to create a breakout room, Eugene, so you can work with Alex? How do you want to
I think
do it?
I could just go over it in here.
Go over here. Okay, that's fine.
Yeah. So welcome to class. The main idea is we're kind of working with drawings again. Yeah. So what you'll want to do is you can find the drawings on a blog on SolidWorks website. So you'll just want to look up this SolidWorks Model Mania and it'll come up. What you'll want to look at is the phase 1 drawings, and I'd recommend the years 2014, 2017, and 2020. In terms of CAD concepts, most of this was review from previous classes. So if you have any questions about how to read drawings, you can ask. I did write some potential features that may be helpful for each of these models. But yeah, let me know if you can find the drawings. All right, so at 6:30, I just want to get a general sense of the pace of things. Don't worry if you're still on your first sketch. It's pretty reasonable pace. How about we start with Daniel? Could you screen share for us?
Okay, one second.
Yeah, no problem. And I'll probably come back again and do it over and again at the end of the class when you have more progress. So I just want to make sure you'll have a good beginning. All right, yeah. So I guess my question for you, I see where you're going with this. Do you have a plan for how you're going to do like the top face of the hub where it's kind of curved?
Not yet.
Okay, yeah, so think about that. This will work. It might take a couple extra features, but looks like you're on a working path.
Okay.
I know Alex just got here, so Alex, are you good in terms of finding where these things are? Yeah, okay, good to hear. Okay, Alex Wu, could you show us what you're doing?
Oh, I'm not done. I'm not. Well, I had some trouble getting on Onshape because I don't know. It's just like my thing restarted. So like, well, it just I had trouble getting on Onshape, and I'm still having. Well, right now I'm almost done. Like I realized the problem and now I'm fixing it. So I didn't exactly have time to do it yet.
Okay, yeah, don't worry. I'll come back later. As long as you're able to resolve your Onshape issue. All right, how about Donna? Donna, could you show us where you're at? All right. Yeah, looks pretty good. So maybe you're just about to do this anyway. Just make sure fully define that sketch pattern, but looks like you're on track.
It's blue. How do you like it's supposed to be black, right?
Yeah, so when you make a sketch pattern, by default, Onshape doesn't assume where the center of your pattern is. So that's the only thing that's not defined right now. If you click on one of the blue points and drag them out, like the center of one of the blue circles,
Oh,
yeah, you can see at the center that center is not. So what you can do is just drag it out a bit more so you can see the center point. Yeah, and let go. If you click the center point and the actual origin, you can just make them coincident with your constraints. It's also I on your keyboard. Yeah.
Oh, okay. Thank you.
All right, next we have Jeffrey.
Oh, sorry. Okay.
Or Peyton, I guess. I wasn't sure who Jeffrey was. Seemed like a. All right, so you're also doing the 2021. I guess same. I have the same thing to say to you as I did for Daniel, which is just keep in mind your plan for how you're going to make that curved top surface. I guess just to illustrate what I'm talking about. Yeah, keep in mind that when you extrude it, you'll just have to figure out some way to make this surface conical. But
Okay.
that is a way that will work. You might have to do an extra feature just to get that top face. All right, next, Luke, could you share? Okay, I think you're the first one I've seen to do the second one. Could you show how you did that sketch? Just curious. Okay, yeah. I guess you probably also realize it, but it might be a bit harder to dimension, but I guess the main point is just to understand the overall flow of creating the model in terms of the parametric design. So in terms of feature tree, I think you have the right idea. Maybe, I guess if that's your goal, that's pretty good. All right. Next we have Selena. Okay, also the second one. So yeah, I do like the way you're going about it. I'm sure you're still working on all the constraints, but the sketch looks good. I didn't quite register, but I'm guessing that you extruded the cylinder first, and then you're going to cut out the little pockets on the first side. And lastly, do you have any questions, Thomas? Everything's fine.
No.
How's the progress?
I'm trying to get I'm doing the second one,
Okay.
and I'm trying to do like what's that? Like what do you like the indent inside the piece? Like not the like the indented part, like the part that goes in.
This part.
Yeah.
Is this what, okay, yeah. Yeah, so that is probably one of the more interesting parts of this piece. One trick is though, you can pretty much use the same sketch for both sides of this part, since you'll notice that this contour really closely follows this contour. So I'll give you another few minutes and I'll just come back, do another pass, see how you've done towards the end of the class. And at that point, I do recommend that you just submit what you had. And as a reminder for the homework, you can just finish the first one if you haven't. If you did finish and you want to do another one, you're also welcome to. And if you really want to, you're free to choose any of the other ones. Every single one of those is a very interesting challenge, maybe even a unique challenge. All right, I'll just start from the top of the alphabetically ordered list. Daniel, could you show us how you're doing?
Change my mind about my first sketch. I made another one because I don't think that first one worked.
Okay, sure. Yeah, I can kind of see what you're going for there. Yeah, so I guess that line.
So I tried to like revolve it because
Okay.
My first sketch when the two intersecting lines, I don't know a tool that can like curve it around, so I just went with a revolve.
Yeah, and in fact, like the revolve is the way that I did it, and I think is a good way to do it. Not that the other one wouldn't have worked, but I'm glad that you came to that conclusion. How about Alex Song? Hopefully you found everything. Sketches are good. Yeah, so another Hub 1 2020. I think I couldn't quite tell, but it looks like you're going for some kind of revolve cut. So seems like you're on the right path. Alex Wu, is your on shape okay? Everything's fine?
Yeah, I just fixed it.
Okay, great. Good to hear. Do you want to share what you have right now in terms of sketches?
Okay. Here's
right.
what I have so far.
We got the first one. Could you spin it around?
Yeah, well, I didn't do the bottom part yet, but I'm about to do it.
Yeah, that's fine.
So,
Yeah. So in terms of the shape, that's pretty accurate, I guess. High fidelity. I guess since it's kind of the end, I will maybe put in my own 2 cents in terms of the models. For this one, I would recommend using the shell feature just because you kind of have like a uniformly thin structure. So what you might do is just create the solid version of this where the whole indentation is filled up, and then you can use the shell feature on the top face and it'll kind of create this shape. There's nothing wrong with the way that the two people who did it. Just one way might be faster, one might be easier to understand. Like I said before, there's as many ways to model a part as there are people who can model. All right. How about Donna? How are you doing? Yeah, so this is the other number 2. Seems like actually you are going for that approach with the shell. I'm not sure if you're trying to say something.
Do I use the shell on this face right here?
Yeah, so if you haven't already, see what happens.
Um,
And the number underneath the box where it says shell thickness, that allows you to control. So I forget what the drawing says, it might have been 3 or something.
okay.
Yeah. And so when you do that, you'll see without too much effort, you're able to make those well shapes.
Okay.
Yeah. I see you've got the sketch for the back already, so good progress. Next, we have Peyton.
I'm not done.
It's okay if you're not done. I know pretty much everyone in the class isn't done. I just want to, if you have any problems, how are you doing in terms of progress? Yeah, so you're going by the first approach. Like I said, this will work. Yeah, I guess just keep at it, see how it works. You'll probably end up doing something similar to what Alex's song, I think, had, where you have the extrusion and then you have a revolve cut. At least I think that's what I saw there. So, all right. I'm getting a message from Zoom that my internet connection is unstable where I live. Yeah, so I see in the chat. If you do have to leave, that's fine. Just as usual, homework is, I guess, perhaps differently from usual. Homework is just to finish the one you had. You can submit an image or a link in the assignment, and otherwise I'll just see you again next week. Yeah. Selena, would you like to share how you're doing? All right, I like the sketch definitions. Seems like good progress. I guess